Hello everyone, myself Forum, Assistant Professor of EC Department at LG Institute of Engineering and Technology. Welcome to the session of Radar and Navigation Aids. So, in the previous session we have finished unit number 6, that is electronic scanning and the principle of electronic scanning, right? So, in today's session we are going to start unit number 7, that is navigation. Now, first of all, what do you mean by navigation? Now, before starting the definition of navigation, we must know that in chapter number 7, first of all, what is navigation and what are different methods of navigation. So, in today's session, we are going to study basically the definition of navigation, different methods of navigations like a navigation by pilotage, celestial navigation, navigation by depth reckoning, and the radio navigation. Now, what is navigation? So, navigation means we are going to direct aircraft or spacecraft or submarine from one point to another point. So, it is the art of directing the movement of object from one point to another point along with the desired path is called the navigation, right? So, what are different aids of navigation? We can use compass, chronometer, and the sun, moon, and the stars position. So, we can say that the navigation is the art of directing any object, right? So, what are different methods of navigation? So, a navigation requires what is the actual position of my target, or we can say submarine or the spacecraft. So, based on the actual direction or actual position of the aircraft and the direction in which it has to reach to a specific destination. Alright. So, currently there are total 4 methods of navigation, like a navigation by pilotage. We can say with the help of a visual contact. Second is the celestial or the astronomical navigation. Third is a navigation by depth reckoning, and the fourth is radio navigation. Right? So we will see one by one all this method. First, we are going to focus on the navigation by pilotage. Now, what does it mean? So, in this method, we are going to determine or we are going to navigate the aircraft with the help of its position on the map. So, how we are going to determine it? We are going to determine it with the help of observation of a visible landmarks, like the air navigation when the ground is visible, right? So from that we are able to identify that how far or at which altitude my aircraft is there from the ground, right? Altitude stands for the height from the surface of the earth, alright? So in the air navigation, when the ground is visible, so a navigator can see the principal features on the ground such as rivers, coastlines, and the hills. Okay, so based on that, he is able to fix the position of aircraft. Alright, so this is during a daylight, but what about the night? So even at the night, with the help of light beacons, cities, towns, which provides the information about the position of the craft, right? Now, in the navigation by pilotage, it requires good visibility, right? With the help of airborne radar, it is also known as electronic pilotage. So the radar used for this purpose is such as the microwave search radar, which is provided with the PPI display, on which we are able to determine, we are able to map a direction, right? So the PPI picture has the poor resolution compared to the human eye. Why? Because the angular position is typically a 3 degree, right? So, in the navigation by pilotage, the electronic pilotage radar has the range of 50 to 100 kilometers. That means the total visibility area, right? The visibility area is from 50 to 100 kilometers. That is advantageous in the poor visibility, right? But it can't cover over the sea, right? So both the methods of pilotage depends on the availability of accurate maps of the terrain. So we have done with the help of pilotage. Now second method is the celestial navigation. So it is also known as the astronomical navigation, which is accomplished by measuring the angular position of celestial bodies. So celestial bodies, which we can say that the navigation measures the elevation of celestial body with a different components, different devices like sextant and modes at the precise time at which the measurement is made. Alright, so we are able to direct the aircraft. So in the celestial measurement, the celestial navigation, we need to take two measurements, which is far enough to fix the position of aircraft onto the circle, which is on the face of the globe, right? So if we are able to take two such observations which are made, the position we can fix of the aircraft, which is used to identify as one of the 2 points of intersection of the circles, right? Sometimes if we need the precise position, or we need to fix the position of the aircraft, we can take the third observation, okay? Like this. This figure shows how we are going to take, or we are going to fix the position of the aircraft. Alright? So this is the Earth, and if we need to find out globally that at which position my aircraft is there, so third 3 observations need to be taken for accurately finding the position of aircraft, right? So in celestial navigation, it is the advantages which is relatively independent of external aids, but the disadvantages of visibility should be good enough to take the elevation angles of bodies, right? But it is not possible on the sea level. That means it is used only for the aircraft. We can't use it for the submarines, right? But in the air navigation, with the modern aircraft which is flying at a specific altitude, the altitude is like above the 500 meters, so visibility is always good with the help of celestial navigation. Now the third method, that is a navigation by dead reckoning. So in this method, the position of the aircraft at any instant of time, which is going to be calculated with the help of a previously determined position. So we must have what is the previous position of any aircraft and the speed of the motion with respect to the earth, but in which direction it is along with the direction of its motion and the time which is going to be elapsed, right? As is abbreviated as DR. DR stands for dead reckoning, but the another name is a reduced calculation. So over here we require a less calculation for a measurement and to to fix the position of the aircraft. So most commonly used method for the navigation is the dead reckoning. Alright. But in this method, the direction of the motion of the aircraft and the speed of the motion is required, that is must. Okay? It can be done by magnetic compass. And the second requirement is we are going to use an instrument such as airspeed indicator, how fast the aircraft is moving. Okay, it is situated in the aircraft itself, and the mechanical logging in ships. So airspeed indicator is in the aircraft and the mechanical logging in the ships. Okay, so this can be used in both aircraft as well as for the submarine as well. This navigation most commonly used, right? So dead reckoning navigation method, it is a straightforward if the medium in which my aircraft travel is stationary. Alright. So the navigation by dead reckoning, that means in the air navigation, the wind velocity is generally obtained in the course of flight from the weather broadcast, or we can say the communication with the ground station. Right? We must need to understand what is the wind velocity as well. Okay? In the long flights over water, the modern air operation resorts to a minimum flight path, that is the path which requires a minimum flight time. Okay. So we have done the methods of navigation by dead reckoning. And the last method is the radio navigation. So this method is based on the electromagnetic wave to find the position of the aircraft. Right? That is called the radio navigation. So over here, we have done what do we mean by navigation, what are different methods of navigation like pilotage, celestial, dead reckoning, and the radio navigation that use the electromagnetic wave. So over here, chapter number 7, that is navigation, is finished. But still, if you have any doubt, you can ask me anything on my video email. Till then, thank you for your attention.